Welcome to Ratios and Rates. Let's start with some vocabulary. A ratio is a comparison of two quantities using division. There are three common ways to represent our ratios. We can write them in fraction form, using the word to, or using the colon. But the order that those numbers come in is important. If 3 is my numerator, it's always going to be the first number in my ratio. If 4 is my denominator, it's always the second number. I never want to switch the order. A rate is a ratio of two quantities using different units. So here I'm comparing two numbers, 60 and 2, but 60 stands for miles and 2 stands for hours. Because they have different units, it's referred to as a rate. A unit rate is a rate that has a denominator of 1. So if I took this rate and I reduced it, I would have 30 miles over 1 hour. This is a unit rate. Unit rates are often read as 30 miles per hour. The word per means 1. A complex fraction has at least one fraction in the numerator, denominator, or both that is a fraction. So we're used to having fractions with integers for our numerator or denominator, but if we have a fraction as our numerator or a fraction as our denominator, or in this case both, that is referred to as a complex fraction. Let's take a look at some ratios. We've got 45 males and 60 females on a subway car, and we're being asked to write some ratios that refer to this subway car situation. So first they want males to females. So there are 45 males for every 60 females in this car. So 45 goes first because they're asking for males first, compared to 60 females. Now ratios can be reduced in the same way that we reduce fractions. So 45 and 60 are both divisible by 15. So I'm going to divide both of them by 15, and I get 3 males for every 4 females. That can also be written as 3 to 4 or 3 colon 4. Now if they ask me to reverse the ratio and put females first compared to males second, I can just reverse my order. 4 over 3, 4, 2, 3, or 4 colon 3. Now I don't want to take this improper fraction and turn it into a mixed number, because right now this stands for 4 females for every 3 males. If I turn it into a mixed number like 1 and 1/3, those numbers lose their meaning. So always keep ratios in improper fraction form. We can reduce them, but we don't want to change them to mixed numbers. Lastly, I'm being asked to compare the amount of females on the subway car to total passengers. Even though the number of total passengers wasn't given to me in the problem, I can find it by adding up the number of males and females. So there are 60 females compared to 105 total passengers. And once again, both of these numbers are divisible by 15. So I can reduce it, and I get 4 females out of every 7 passengers, or 4 to 7, or 4 colon 7. Now let's look at a ratio table. This ratio table is showing the cost for different amounts of artificial turf. So they want us to find a unit rate given in dollars per square foot. So the order is important. They want dollars first and square feet second. So we're given a couple different options here. For $100, I get 25 square feet. For $400, I get 100 square feet. For $1,600, I get 400 square feet. And for $6,400, I get 1,600 square feet. I don't need all of those ratios. I need to pick one. So I'm going to pick the smallest and easiest one to work with. For $100, I can get 25 square feet. Now I'm being asked to turn this into a unit rate. Okay, so since they are talking about a rate here, I want to include my units. $100, This is for 25 square feet. And a unit rate means I want to get my denominator to be 1. Well, in order to reduce this, I'm going to be dividing my 25 by 25. So I want to do the same thing on top. 100 divided by 25, and I get 4. So it is $4 per square foot. This per means 1. So for $4, I can get 1 square foot of artificial turf. We can also look at ratios and rates on graphs. So here we have a graph showing the speed of a subway car, and they want us to find the speed in miles per minute. So once again, the order is important. Miles first, minutes second. So we've got a couple different points on this graph. The time is listed here on the x-axis, and the distance is listed on the y-axis. So I'm going to look at this point right here. So if I go over 3, which represents 3 minutes, and up 1.5, which represents 1.5 miles, I've got a point on this graph. So after 3 minutes, the subway car has gone 1.5 miles. So they want miles per minute. So I'm going to write the 1.5 miles first. And it takes 3 minutes for the subway car to get this far. So I want it to be out of 1 minute. So in this case, to reduce my denominator, I am dividing by 3. And I'm going to do the same thing to my numerator. I'm going to take 1.5 and I'm going to divide it by 3. So another way of representing 1.5 is 3 halves. And if I'm dividing it by 3, that's the same as multiplying by the reciprocal. I can cross reduce here, and I get 1/2. So the subway car goes 1/2 mile per minute. This is also known as a complex fraction because I have a fraction as my numerator. So it goes 1/2 mile per minute. I also see there's another point on this graph that's very clearly labeled. It said after 1/2 minute, the subway car had gone 1/4 of a mile. So I could also have used that point. It goes 1/4 of a mile in 1/2 minute. In this case, when I'm trying to get to my denominator of 1 minute, I actually need to increase my 1/2 minute. So in this case, I would be multiplying by 2. So I would do the same thing to my numerator, and 1/4 times 2 gives me my 1/2 mile. So it's the same answer, just another way to get the same answer. It really doesn't matter which point I would have picked from the graph. All right, we're mixing 1/2 cup of yellow paint for every 3/4 of a cup of blue paint to make 15 cups total of green paint. They want to know how much yellow paint and how much blue paint should we be using. All right, so we're combining our yellow paint and our blue paint to make green. So if I use 1/2 cup of yellow paint and 3/4 of a cup of blue paint, and I can write them with common denominators here, I'm actually mixing up 5/4 or 1 1/4 total cups of paint. Now we want 15 cups of paint. So all of these things are going to have to increase so that we can get to 15 total cups of paint. So I'm going to try to figure out what am I multiplying 5/4 by that gets me to 15. So I'm going to work backwards. I'm going to do 15 divided by 5/4. which is the same as doing 15 times 4/5. So I can do some cross reducing here, and I get 12 over 1, or 12. So I'm multiplying here by 12 to get to the 15. So I want to do that for my blue paint and my yellow paint. So let's start with the yellow paint. We started with a half a cup of yellow paint, and we want to increase it by 12. So I'm multiplying by 12. Can do some cross reducing here, and I get 6 over 1, or 6. So I need in total 6 cups of yellow paint. Now for this one, 3/4, I'm also increasing it by 12, so I'll multiply by 12. And I can do some cross reducing, and I get 9 over 1, or 9. So I need 9 cups of blue paint. So 6 yellow and 9 blue would make my 15 cups of green paint.